Degree of multiprogramming means the number of processes that are resided in main memory at the current time. Okay, the number of processes that are resided in the main memory. Okay, so if there are 4 processes that are resided in the main memory, we'll say that degree of multiprogramming is equals to 4. If there are 10 processes that are resided in main memory, we can say that degree of multiprogramming is 10. Okay, so at any point of time there are n number of processes that are loaded in the main memory. There is no fixed number of processes that are loaded in main memory. We cannot give any restriction. Okay, so each address that are related to this particular main memory will call physical address. Okay, physical address, and this particular logical address means the process that are stored in hard disk. Okay, the process that are stored in the hard disk is again divided into some particular divided, okay, and given some address. These addresses are called logical addresses. Okay, right. So there is a set of all physical addresses, we'll call it as physical address space of a process. Okay, the set of all logical addresses are called logical address space of a process. Okay, set of all physical addresses we will call it as physical address space of a process that belongs to main memory. A set of all addresses of process we will call it as logical address space. Okay, that means if a process that is of 100 bytes. Okay, the process is of 100 bytes. Out of 100 bytes, all the 100 bytes are may not be stored in the main memory. Only some part of the memory is stored into main memory. Okay, so then suppose that if there are 50 bytes of memory are stored into main memory, then these 50 bytes we will consider it as physical address space of the process. Okay, but what is the actual size of the process? 100 bytes. Okay, so logical address space is 100 bytes. Physical address space is the number of bytes that are stored in main memory, that is physical, the collection of all physical addresses. Okay, so the difference between logical address space and physical address space. Okay, so these logical and physical addresses, okay, what is mean CPU will generate logical addresses. CPU will generate logical addresses. Okay, so the size of this particular process that is stored in the main memory, the size of this particular process that is stored in the main memory, we already told that that is stored in limit register. Okay, so whenever the CPU takes the instruction from this particular, okay, process and loaded into CPU, loaded into CPU, the CPU will generate a logical address. CPU will generate a logical address. Suppose that the process size is 100 bytes. Okay, so process size is 100 bytes. The limit register value consisting of the value 100. Limit register value consisting of the value 100. Assume that the starting address of this particular process, the base register value, okay, base register value, assume that 700. Okay, so what is actual size of this, our actual memory locations of this particular process? Assume that process px, the actual memory locations are including 700. Okay, it is next from 700, the next 100 bytes are belongs to px. Okay, that is 700 to 799, because 700 is also included. So 700 to 799 is belongs to process px. Okay, so let us take 800 to 899. Okay, this is also the next process is also size of 100. This is belongs to process py. Okay, when CPU generates an address that is called a logical address, that means this particular address has to be fetched, but the CPU does not generate the physical address, because CPU doesn't know where the actual memory locations of memory location that is reside the process reside in the main memory. So CPU, what CPU do? CPU takes the data from large limit register. It will take 100, okay, and it will generate a value called 34. Assume that it has generated a value called 34. That means this particular 34, okay, 34th byte, this particular 34th byte data is needed by CPU. Okay, so this particular logical address has to be converted into physical address where this particular data is stored in the main memory. Okay, so the process of converting logical address to physical address is the responsibility of memory management unit. Okay, the responsibility of memory management unit is converting of logical address to physical address. So who actually generates the logical address? CPU. Based on which register value? Limit register value. Now once the CPU generates the logical address, okay, this logical address value must be less than limit register value. Condition 1, whatever the address that is generated by CPU, that it must be less than limit register value. Okay, so what is the value? 34. Okay, is 34 less than 100? Yes, the first condition is satisfied. Second one, if this condition is satisfied, then the system, the memory management unit, looks for base register value. Okay, looks for base register value and fetches the base address, base register value, and fetches the base address. Okay, so what is the base address here? Assume that px is loaded in 700. Okay, base address value is 700. Okay, and adds this particular 700 to logical address. Okay, so what is the result? 700 plus 34, the value will become 734. Okay, so this 734 is called your physical address, that is the memory location of your process that is resided in main memory, that is 734th memory location data needed by CPU. Okay, needed by CPU. Okay, so here the responsibility of generating physical address is taken by memory management unit. Okay, memory management unit. Okay, so what is responsibility of memory management unit? If CPU generates a logical address that is 34, this logical address should be less than the value of your limit register. So if this particular 34 less than 100, okay, it is satisfied, then we'll fetch the value of the base register value, that is 700, and adds the logical address, that is 34, and generates an address called 734. This is physical address, the actual memory location of your main memory. Okay, a memory location of main memory. Why this particular condition, that is logical address must be less than your limit register value, will protect the process in the memory, because at any point of time there are multiple processes that are loaded in the main memory. Okay, so assume that there is base register value 700, this is process px, and 800, this is process py, and some 900 and some 1100 something. So these are the base register values of this particular process. So when it comes to size, the size of px equal to 100, size of py equal to 100, and size of pz equal to 200. Okay, suppose that if the logical address that is generated is more than this particular limit register value, suppose that if the logical address generated is 102, generated is 102, if this particular 102 is actually less, has to be less than limit register value, but what is the limit register value? 100. So this is failed. Okay, if you don't check this particular condition, then this particular logical address value 102 is added to base address, that is 700, and what is the memory location that will get? 700 plus 102, the memory location will be 802. But 802 is actually belongs to py. 802 is actually belongs to py. So this particular px cannot access the data that is stored in 802 because 802 belongs to py, the second location, memory location of py. Okay, so that's why this restriction, logical address less than limit register value, this restriction is used to protect the process from different processes in the main memory. So that will restrict to access one process to does not access another process memory. Okay, so this restriction will give you the protection of memory protection of a